In example 6.5.1, what we're trying to decide is if we would treat the problem as one where we would do a difference in means, where we look at mu1 minus mu2, where we have two independent samples, or if we would treat it as a paired difference, which is the stuff that's covered in section 6.5. When we look at a paired difference, we do not think of the two samples as being independent, but as being related, and so we treat those differently than what we were doing in the earlier section. So in part A, we have a medical study where we're trying to learn about the difference in generic versus name brand blood pressure medications. So we have 50 men and 50 women randomly assigned to receive either the generic or the name brand medication. So for this case, the 50 women's blood pressures and the 50 men's blood pressures should not be impacting each other at all. These are completely separate groups of people. And so these would be independent samples or difference in means, we would say. So we would do what we've already learned about back in section 6.4 here. So we would look at mu1 minus mu2. In part B, researchers want to learn about the average age differences between partners who've been together for more than 10 years. So they have 50 sets of partners and ask them their age. In this example, we actually really only think of this as like one sample, 50 sets, and then we have the two people, 1, 2, within that set. When we think about the ages of two people who are together, we expect those to be related. People tend to be with people similar in age to them. So because we have just the same couple here, this would be a case where these two observations of the two ages are not independent of each other, and so we would want to treat this as a paired difference. And so this is because they're from the same couple. So often when we have paired data, it comes from the fact that we have the same of something. In part C, in a study on the average difference in calories between servings of strawberry and vanilla yogurt, a food scientist randomly selected 12 brands of yogurt, recorded the calories in their strawberry and their vanilla yogurts. Notice here we have one sample of 12 brands, and we're looking at both the strawberry and the vanilla for that. So this is going to be a paired difference again. And this is merely because of the fact that we are looking at the same brand. So maybe one type of brand tends to have more calories for both their vanilla and strawberry. A different brand has lesser calories. If we had selected 12 strawberry yogurt of whatever brands and then a different 12 brands of whatever vanilla yogurt, they would be independent. But because they're from the same brand, they're paired. And then in part D, the Office of Greek Life randomly selects 45 fraternity and sorority members and looks to see if there's a difference in the average GPA. So here, these would be separate groups, and so we would look at difference in means. We would have no reason to suspect that their GPAs here should be related to each other. And so this would go back to the stuff in section 6.4. So in B and C, we want to treat these differently than what we saw in 6.4, and so that's the focus of section 6.5 on how do we deal with these situations where our two sets of data are not independent.